Far across the cosmos, astronomers spotted something impossible. A black hole that grew far too quickly.
It shines brighter than entire galaxies, yet it formed when the universe was still young.
At first, they thought the data was wrong, but every observation confirmed the same shocking truth.
A supermassive black hole existed too early, billions of years before it should.
Normally, black holes grow slowly, feeding on gas and dust for billions of years.
Physics places strict limits on how fast they grow. Nature doesn't allow shortcuts.
But this object ignored those limits completely.
This black hole existed only a few 100 million years after the Big Bang, almost at the dawn of cosmic history.
To become that massive so quickly? Something extraordinary must have happened.
Did enormous gas clouds collapse directly into black holes, skipping the birth of stars entirely? Or did countless black holes merge together, growing faster with every collision?
These collisions send waves through space-time, signals we can detect across the universe.
But even these explanations fall short. The math still doesn't work.
So scientists are asking a dangerous question. What if our physics... In the early universe, matter flowed along giant cosmic filaments, feeding the first galaxies. If those streams fed black holes continuously, growth could accelerate dramatically.
But even that might not explain everything. The numbers are still too extreme.
These ancient quasars are quasars. And new telescopes are revealing more of them, each one more puzzling than the last. This wasn't just one strange object. There may be many.
That means the problem is bigger than we thought. Much bigger.
Our models fail to recreate what we observe. Something fundamental is missing.
Maybe gravity behaves differently in extreme conditions. Or new physics is waiting to be discovered.
Because somewhere in the early universe, a black hole grew faster than physics allows.
And if we can understand how it formed, we might unlock a completely new chapter of cosmic physics.
In the distant universe, something impossible was discovered. A black hole.
This object shines brighter than entire galaxies, yet it existed when the universe was still young.
When scientists first saw it, they thought it was a mistake. But the data kept confirming the same strange result.
A supermassive black hole had already formed, and it shouldn't have existed yet.
According to current physics, black holes grow slowly, but this one broke every rule.
Normally, black holes form when massive stars collapse. Their gravity becomes unstoppable.
Gas spirals inward, forming a blazing disk. That's how black holes slowly gain mass.
But even at maximum speed, growth takes billions of years. The universe simply hadn't existed long enough.
This black hole appeared only a few 100 million years after the Big Bang. That's astronomically early.
Look at thermal dating. You deserve.
So how did it grow so fast? That question is shaking modern astrophysics.
To understand the mystery, we must rewind cosmic history, back to the universal's first stars. These stars were enormous, hundreds of times heavier than our sun.
When they died, they left behind the first black holes, seeds of future giants.
But even these seeds were tiny, only a few hundred solar masses.
To reach billions of solar masses, they needed far more time.
Physics limits how fast matter can fall in. Too much pressure pushes gas away.
This limit is called the Eddington limit, nature's built-in speed cap.
It prevents black holes from growing too quickly, at least in theory.
But this new black hole ignored the rule. It grew far beyond expectations. So either our calculations are wrong, or something extraordinary happened. Powerful telescopes scanned ancient light. The signals came from billions of years away.
The light was stretched by cosmic expansion, a message from the early universe.
Hidden in that light was a monster, a billion solar mass black hole.
For something this massive to exist so early, physics struggles to explain it.
One idea suggests giant gas clouds collapse directly, skipping the star stage entirely. If true, these objects formed enormous seeds, thousands of times heavier.
But even that might not be enough. The growth is still too fast.
Another theory suggests frequent mergers, black holes combining again and again. Each collision releases waves in space-time, signals we can detect today.
But mergers alone cannot explain everything. The mystery remains.
New telescopes are now searching deeper for clues hidden.
Their mirrors capture faint infrared light, light older than most galaxies.
Inside those galaxies, monster black holes are already active.
These objects are called quasars, the brightest beacons in space. Their energy comes from matter falling inward, feeding an invisible giant.
Some scientists think early gas flows were extreme, fueling growth at impossible speeds. The universe was denser then. Gas flowed along cosmic filaments. Those streams may have fed black holes non-stop, breaking normal growth limits.
If that's true, the early universe was far more violent.
And black holes grew like cosmic monsters.
Yet the numbers still don't fully match.
Some equations may be incomplete.
Maybe new physics is hiding.
Perhaps gravity behaved differently.
Or or matter fell faster than expected.
Our simulations might be missing key processes. So scientists keep searching. Each new observation adds clues, and every clue deepens the mystery. Something in the universe allowed impossible growth.
Some theories involve quantum gravity.
At tiny scales, space-time may behave differently.
Perhaps black holes can bypass growth limits.
Others propose dark matter played a role. A hidden fuel source. Dark matter dominates the universe.
If it fed efficiently,
Massive objects could grow earlier.
But evidence is still uncertain.
Every theory faces challenges.
Some discoveries may even be illusions.
Gravity can magnify distant objects.
But even after corrections,
the black hole remains enormous.
Too massive, too early.
which leaves one possibility.
The early universe was stranger than we imagined.
Structures formed faster, and black holes grew violently.
If true, our models must change.
The universe still holds many secrets. Each discovery pushes physics further.
And new observatories are coming.
They will see deeper than ever before.
Perhaps they will solve the puzzle.
Until then, the mystery remains. A beacon from the ancient universe.
More of these giants are being found,
suggesting the problem is widespread.
Not just one impossible object,
but an entire population of cosmic giants. They shaped the first galaxies and influenced cosmic evolution.
Understanding them could rewrite history.
And maybe reveal new laws of physics. This black hole remains unexplained. A challenge to everything we thought we knew.
Proof that the universe still surprises us.
Even after centuries of science.
But every mystery leads to a greater discovery.
and pushes humanity forward.
The universe is still young to us.
And we've only begun exploring it.
Somewhere out there.
More impossible objects are waiting. Waiting to challenge physics again. And remind us